and gentlemen, boys and girls alike, welcome to the first episode of the Foundations of Excellence in Mathematics, Chapter 2. We're starting with real-life situations, real proofs, and many more to come, featuring FEM CEO, host, and tutor for this video, Landon Pitts.
Hey everybody, what's going on today? Welcome to today's episode of the Foundations of Excellence in Mathematics, where we make math come to life and we have a goal to make math be true. So, what are we learning for today's lesson? That's a great question. I will get to that in one moment while I write something on the board. Alright, welcome back, and now we have some stuff on the board. So, here's our agenda for today's lesson. So, we're going to, first of all, we're going to wrap up Unit 1 for Algebra 1. We're going to get down to what we did from last time. And if I remember correctly, we did two-step equations. And now we are going to do absolute value. We're going to do word problems. And then there's one more. But we'll go through each one of them and we'll apply it to the real world. So, how are we going to solve these problems? How are we going to apply them to the real world? Well, this is FEM, the Foundations of Excellence in Mathematics, where FEM meets culture and improvement. And now, here it is, the new and improved FEM Core version 2.
Let's go! It's a new day in the new year of 2026. The FEM is going to be the reason the math this semester will click. Homework, test assignments, and the final examination. But now FEM is back, and it's laying the foundation of excellence in mathematics. That's a code name. That's the name that was built for as well-deserved fame. Talking from the high school ground zero, continuing with Algebra 1, and then it's up to AP Calculus when FEM will be done. The challenge will be scary, but we'll prove the teachers false, and FEM will soar through it like we're dancing the good old waltz. So let's take on the challenge together and end the students' suffering. We may even be the reason that students are recovering. FEM Core. FEM Core. FEM Core. FEM Core.
That was FEM Core version 2. You can check it out on Spotify, Amazon Music, YouTube Music, Tidal, Deezer, all of the platforms that provide music. But now, without further ado, let us get started with the math thing. So, let's do this. Let's go ahead and erase all this stuff, because we won't need it for now. But we can always come back to it later. So I want to go ahead and do that real quick. By the way, before we do continue, yes, FEM is officially going in the real board, because one thing that we notice is that when we do online teaching, it is way better, whereas doing teaching via the iPad, where I use an Apple Pencil, it was not efficient enough for real teaching. But now I'm here. I'm Landon Pitts. I scored a 710 in SAT math. I have an A. I am in pre-calculus right now, which means that I am an official Upchieve tutor and Schoolhouse.World tutor, which means that if anyone has any inquiries, you may contact femhelpservices@gmail.com. I am available 24/7, and just email me and I will respond within 24 hours, and I'll try to respond as soon as possible if I can. So, yeah. Okay, let's go ahead and talk about absolute value. So, let's see here. First things first, what is absolute value? Absolute value, by definition, it's basically the distance from zero. So here's what I'm gonna do. I'm gonna bring you a little closer, because I don't want anyone to get lost during this lesson. So I'll go ahead and bring you a little closer so you can see. So I got some problems up here, right here. But before we do, let's go ahead and just write down what the absolute value really means. So I'll go ahead and write it on the board real quick. All right, so we're back. Now we can see we have some formulas and some information right here. So the absolute value is basically the distance from 0. That's the simplest definition I can really give you. There's nothing else to absolute value. Don't worry, guys. This is a very simple topic. Once you nail it, there are only 2 formulas with this topic. First of all, the absolute value of x, positive x, will always just be that same value. And the absolute value for negative x will also just be positive x. Now, the distance from 0. So here's an example. So we know that distance cannot be negative because let's just say for example, I'm 6 feet tall. Now, what if I was like to the left? Like, what if I'm, just say, 1 feet wide to the left? Now, to the left, that does sound like negative, but that's not possible. Like, I can't be -1 feet wide or like -6 feet tall. That wouldn't make sense, right? Yeah, that wouldn't make sense. So, basically, let's just say, like, we're starting at -4. Now, we want to go to 0 because it's the distance from 0. So, we want to count 1, 2, 3, 4. So, -4 from 0 is 4 units away from 0. And then -6, since it's positive, it'll just be positive. So, it'll be 1, 2, 3, 4, 5, 6. Suffix. And also, in absolute value, we can have multiple answers. So, like, for example, like 6 and -6, those are both 6 units from 0, right? So that means that our x can be 2 possible values in most cases for absolute value. So there's that. Now, based on what we learned, we can go ahead. I'll do this first problem on my own. We'll do this simple one. We have absolute value of x equals 1. So what's x? So we have 1. So we want our answer to be 1. So that means we want our answer of x to be that many. So like we want a value that is 1 unit away from 0. So what's a number that's 1 unit away from 0? Well, we can count, 1 right there, because 1, if we move it backward, that's 1 unit away from 0. So that means x can be 1. Now, are we done? No, because like I said, in most cases, we can have 2 answers for absolute value. So let's just go ahead and take this next problem right here. X equals, so what's another number that is 1 unit away from 0? -1, because -1, if we count, 1, right there. 1 unit. See? Easy. So there you go. X is 1, and x is -1. So there's that. Okay, so now we answered that problem. Now go ahead and you can pause this video, go ahead and solve this next problem. It's the absolute value of 2x equals 4. And remember that there can be 2 possible answers for this one. There can be a positive and a negative in most cases, and there's that. So go ahead. Okay, now that I gave you a little bit of time to pause, let's go ahead and go through this together. So now we have a 2 inside of our values. So what we're going to do is we're going to understand different types of graphing transformations. Now, there are 2 types. There are stretches. So let's see here. Let me write this real quick. Okay, so here we go. So I wrote some stuff on the board. We have 2 types of transformations. We have graphing transformations. We have a stretch. And then we have a compression right here. So 2 types, very important, very crucial to know. So a stretch. Now, there are also 2 types of stretches and compressions. Now, those are vertical and horizontal. Now, vertical, whether it's a stretch or a compression, will always be outside of the absolute value. So basically, stretch we can abbreviate as a to the x, where a is equal to a number, and a compression is when a is inside the x. So a is outside when it's a stretch, and a is inside when it's a compression. So it would be ax, where a is equal to a number. Now, based on what we learned, let's just pretend that a is equal to 2 here. So would it be a stretch or a compression? It would be a compression because 2 is inside of the absolute value. So what this would mean, and this isn't important for like solving it actually. We will need to know that for later though, because well, Well, first of all, we're going to be graphing later because absolute value is one of the key graphing things. And we'll cover a lot of graphing in Algebra 1, but as of right now, we're doing absolute value. We will definitely do way more graphing later. So, all right, let's get back to the problem. So, we have 2x, which means that we want to find a value of x that will make 2, have a distance of 4 units to 0. So, essentially, 2x needs to equal plus minus 4. You're probably wondering, how did I pull that out? Well, I'm going to prove why that's true right now, because remember, we want that many units from 0, because whether it's positive or negative, it'll always be that many units from 0. So that's pretty simple. So that means that the value of x's for this one and this one will be the exact same. So if you want to put it like that, you can. But just so I don't confuse it that much, we'll stick with absolute value, but you are totally welcome to use that thing. Matter of fact, I'll leave it on the board right over here. 2x is equal to plus minus 4, and that's also 2x equals 4. So there's that. You can keep that. You can use it for reference right here. Put a star right there. You can use that for reference right behind me. But anyway, 2x equals 4. So x, okay, so what equals 4? Like, we would want to divide by 2. So 4 divided by 2 is 2. So that means that x is equal to 2. Now that's one value. Now what's the other value? Now be careful here, because if we try to plug in -2 for this problem... No, wait. No, I lied. It is -2. Whoops. Okay, so 2 times -2 would equal -4. And that's 4 units from 0. So that works. X equals 2, x equals -2. So there we go. We did 2 by ourselves. Now, I want you to do this next problem individually. So, now I want you to, now, let's just give you a problem. Let's see here. What can I give you? How about 3x equals 12? So go ahead, pause this video, solve this problem right here, and then we'll come back and we will discuss. Okay, I think I gave you enough time to pause. Still need time to pause. Go ahead and pause at any time, but we're going to solve it now. So, x right here, we want it to be 12, positive or negative. So, x will have to equal, because 12 divided by 3 is 4. So that means x is equal to 4. Now, we want, because 3 times 4 is 12, that's 12 units from 0. Now, what's the other number that will also get 12 units from 0? -4. Yes, perfect. So that means that x is equal to 4 and -4. Basically, what I'm trying to say with these problems, you're usually going to get x equals plus minus a, where a is, well, the answer to your problem. So that's that. Now we're going to get into more complex absolute value. Now don't be scared, because I know it can be a little scary and a little frightening at first, but don't worry, we're going to do it together. So, let's see number 3 right here. And actually, matter of fact, oh, no, I'll keep it up. Number 3, we have 2x plus 1 equals 4. So now what we want to do, so what should we do first? Because we want to understand that, and this is why we'll need transformations later, because we're going to want to understand all of that processing, so that way it's going to be a lot easier for us to graph it. So, 2 absolute value x plus 1 equals 4. So from our last video, we want to cancel out the 1. To do that, we have to subtract by 1 on both sides. Now this is because 1 minus 1 is 1, and if we do the exact same thing to 2 sides, it'll be the exact same thing. So it's kind of like losing weight. Like if one person loses 1 pound on their side and the other loses another pound on their side, then it'll be the exact same because they both lost 1 pound. Kind of like in like a weight challenge, you know what I'm talking about? I hope you do. But anyway, so 2x equals 3. And now, here's a good thing I like about vertical stretches or compressions. They can be divided by 2 immediately. So basically, since the 2 is outside of the absolute value, we can divide this by 2, which means that the absolute value of x is equal to 3 over 2. And now, let's just follow this rule. X is plus or minus a, where a is 3 over 2 in this case. So let's just say x is plus or minus 3 over 2. And boom, we're done. So now let's go ahead and see what would happen if 2 was inside of the x and not outside. So if we go over here, I'll erase all that real quick. What if 2 was inside and not outside? Well, then it would just be the exact same scenario as this thing. So we would find a number that would equate for 3 over 2, and that number would be, looks like it is, all right, well, obviously I don't have a calculator in hand, but, it would be about, 0.75, but, don't count me correct here, because, these ones are kind of tougher, so you might require a calculator for these types of problems. But anyway, for this problem, it is going to be plus minus 3 over 2. So that's that. I will keep the answer up, just so you can have it. And I will put plus minus, but please understand that it's positive and negative. Okay, last problem. It's a little more complicated, but in this time we have x over 2. Now, another way we can write this is still going to be a compression because it is still compressed inside of the absolute value. So that's one way you can remember that thing. It's just you can compress. So now let's go ahead and solve as per usual. Minus 3 plus 5, want to add these on both sides. So plus 3 right here. So that means we were left with 3x over 2 equals 8. Now we want to divide 3 on both sides since vertical lines can be done this way, so 8 over 3. And now, to make this a little less confusing, I will write this as 1/2 x equals 8 over 3. And actually, matter of fact, this will be a stretch now, and I will explain that in a moment. So, stretches and compressions. Let me tell you a little something about that. Stretches, when they're in the outside, if a number is greater than 1, then it's going to be a stretch. However, in compressions, when the number is greater than no. I lied. I messed that up. In vertical transformations, when the number is greater than 1, it's going to be a stretch. When the number is less than 1, it's going to be a compression. Now, this is only the case if the number is like in between -1 and +1. If the number, if the absolute value of the number is like greater than 1, like we explained, it's going to be a stretch. Now, this is only the case if they are like outside. So if it's inside of here and it's less than, greater than or 1, then it would be a so inside it would be a compression. Now, we'll need this for later for graphing, but let's go ahead and just go ahead and solve the rest of this problem right here. So remember, we want to make sure that our answer is units to 0. So we want an answer. So let's just go ahead and actually let's take out the absolute value. 1/2 x equals 8/3. We'll do a positive, and we'll do a negative. So we'll do positive and negative. So there's that. And now we want to get x by itself. And to do that, we need to divide fractions. To divide fractions, we have to divide 1/2 on that side. Now, x will be equal to -8/3 divided by 1/2. Now, when you're dividing fractions, you want to multiply the reciprocal. So dividing by 1/2 really just means that you're multiplying by 2. So that means that this would be 2 over 1. Now the reason is that division, you're cutting numbers. So if you divide, so let's just say you divide by 2, so you do 2 over 2. Basically what division really means, it's just repeated subtraction. So you do 2 minus 2, and you just keep subtracting until it eventually gets to 0, and then that's that. So now if it's just divided by 1, you would divide by 2 twice, and it would just you would subtract by 1 2 times, because 2 minus 1 minus 1, you're subtracting 1 2 times. So what dividing fractions would do is 2 minus 1 half minus 1 half minus 1 half minus 1 half. 4 halves equal 2, so that means that you're actually gaining more. And that's also kind of why you can't divide by 0, because say 2 minus 0 minus 0 minus 0 minus 0 minus 0 minus 0, and so on and so forth. You will never get to 0. You will end up with 2. So it's just it's just infinity, undefined, as some say. But anyway, negative 8/3 times 2 over 3. So this would be, what's negative 8 times 2? 16. Good job. And that would be on top. And then 3 times 1 should just be, so x is equal to negative 16 over 3 right here. That's the negative one. And now the positive one, let's have you do it. Now, will it change or will it stay the same? Go ahead and pause the video right now if you want. Okay, I gave you some time to pause. Let's see here. So we want to divide by fractions again. So we have 8/3 divided by 1 half, or in this case, just multiply it by 2, 1. 8 times 2 is 16 over 3. So yeah, that means x would be plus minus that same thing again. So there's that. That one will be 16 over 3. And yeah, that's pretty much all you really need to know about absolute value. So great job. We covered that in 20 minutes. So now what I'm going to do is I'm gonna give you a quick little quiz. Let's make the thing, I'll give you 10 questions. Oh, actually one more thing. Now we have to make it so that way we can make absolute value relevant in the real world. So we are going to test this concept, and then we're gonna give you, okay, so we're not gonna do a quiz yet. Hold on to that thought. We are going to do a, what's it called? Oh, real world scenarios. So here's what we're gonna do. First, we're gonna erase all this. If you need to take a screenshot, go right ahead. I'll get out of the way for you guys. All right, there you go. Hopefully glare wasn't that much of an issue. So let's go ahead and erase all this real quick. Let me go ahead and pause, and then I'll come back to you when I'm ready. All right, so I got the first scenario up here. It may look long, but please, for the love that all is holy, don't let that scare you. I know it looks long, but trust me, when we break it down, it's actually very simple. All right, follow along. I'm going to give you guys a moment to pause. You can go ahead and pause and read that problem right there, and then I'll read it to you, and we'll do it together. Okay, so here's the first real life scenario. You will need this for the future because trust me. Assuming you guys are in Algebra 1 and, I don't know, like 7th grade, 8th graders, freshmen, sophomores. I'm assuming you're not, like, driving a lot yet, but once you do, you will be doing speed limits. You'll have to know speed limits. So, here's the problem. You're driving on the interstate to go see your friends to hang out. However, you don't want to get charged fines to your credit card, or else your parents will take away your belongings. And the law says that you are not allowed, I forgot to put that word, you are not allowed to go more than 5 over or under the speed limit, as this can result in heavy fines depending on the severity. And additionally, oh wait, ignore that part, whoopsies. Ignore that. Okay. As this can lead to severity, period, end of question. All right, so first part, find a safe speed limit range and use absolute value, just as we learned, so no fines happen. And identify the fine if you go 80 miles an hour. So let me tell you about the fine formula because it can be a little confusing, but here's the formula you will want to use. It is x minus 25, absolute value is less than or greater than 5. Now, this thing, it has to be like true to determine the range. Now, if the x value makes this formula false, the formula is it's $10 and then depending on how high they went up, like, it would be that number out of range. So, let's just say you were going 72 miles per hour. So, oh, and speed limit, it's not 70, it's supposed to be 65, because, I put that wrong. 65. Awkward. Okay. Anyway, so you're going 72 miles an hour, so you have 72 minus 65, which is 7, which is not less than or greater than 7, which means that that is false right there. Now, 7 minus 5 equals 2. 2 times 10, which means that if you go 72 miles per hour on a 65, you would get a $20 fine. And your mom would take that, what's it called? She'd get the belt, and, she would kind of whoop you. Yeah. So, well, I hope that's not real life, though. This is just a scenario. Don't worry, none of this is real. But, let's just say, maybe they just still take your belongings, though. Like, they take your phone, your iPad, and, like, they would make you study math, which, I mean, hey, this is a math channel, so, like, what can I say? But anyway, let's see here. So, now, I'm gonna give you guys some time to solve find a safe speed limit range. So in other words, find the range for which this is true. And then identify the fine if you go 80 miles an hour. So go ahead, pause, and then we're going to solve it together. All right, I think I gave you enough time to pause. So let's go ahead and solve it together now. So we want a safe speed limit range. So we want x in here to make it true. So let's just go ahead and make x minus 65 equal to, let me get some room over here. X minus 65 is equal to 5. X minus 65 equal to negative 5. Because, remember, we want positive and negatives for units over 0. So now, 65, let's add that on this side. So x equals 70, and honestly, that's it. That's the high number. Now, x minus 65, negative 65, plus I messed that up. 65, no. Negative 5 plus 65. Now, what is that answer? 60, yeah. So that means that it would be 60. So there's your low number, there's your high number. Now, we want to put it in the format of the low number less than or equal to x less than or equal to 70. So let's do the low number, 60, less than or equal to x less than or equal to 70. So that means that we have to be in between 60 and 70. So let's put that in our MPH range, 60 less than or equal to x less than or equal to 70. So there you go. All right, now part B. Let me check your understanding. So now we want to identify the fine if you go 80 miles an hour. So we can use this for reference right here. So we're just plugging in 80 for x. We're just trying to find, so let's do 80 minus 65. 65 is equal to 15. That is definitely not less than or equal to 5. So we do 15 minus 5, since that's this number right here. That'll be our formula. Equals 10. Now 10 times the number out of range, that means our number out of range is 10. 10 times 10 is 100. 100. That is one Benjamin Franklin bill you are taking out of your pocket if you go 80 and a 65. So yeah, $100. So there you go. That's scenario number 1. Now we're going to do another scenario, and we're going to have you try it again. So I'm going to go ahead and cut the video, and we're going to go to another scenario, just like this one. So I'll see you once we clip. And all right, I got the problem now, and honestly, all this math is making me hungry. So what we're going to do? We're going to make some dinner. Okay, so here's the scenario. Go ahead and pause, take a screenshot of it, look at it. Let me adjust this camera. Perfect. Okay, go ahead and screenshot that, read it, and do whatever you need to do to work on it, and use absolute formula. Okay, So let me just put some boxes for our answering. So here's what we're gonna do for number A. Here's that for number B. Probably don't need this space, but hey, this whiteboard's pretty big, so we're gonna just do what we can. All right, here we go. You're making yourself dinner. The meal's recipe says to make the food at 285 degrees Fahrenheit. The recipe also says that if you're 20 degrees off, the food will be too hot to eat. So your first step is to make a formula to find a safe cooking range. Add a period there. And it also says, the recipe says to cook the food for 13 to 17 minutes. So you want to make another formula that satisfies this requirement. So here's what we're going to do. We're going to make two formulas. So we're going to make two formulas. One for the temperature requirement and one for the time requirement. So A is going to be our temperature requirement. So we want to, oh, hang on. Get over here. That's embarrassing. Okay, let's see here. So we want to make the food. So let's go ahead and we want 20 degrees off. So that means that we know that our thing, it can't be more than 20. But if you're 20 degrees off, yeah, so that means we cannot be 20 or, well, actually it can be exactly 20, but no more. That's what that means. So we have 20 right here. Now we want to find a scenario where if you do too much or too little, it'll be too hot. So let's see here. 20 degrees off. What is 285 plus 20? Let's start with that. 305, yeah. So 305 and 285. So is 305 off from 285? Yeah, it is. So that means that it's going to be part of our range. So we got to find, okay, so we got to find a way to make this true. So I'm going to put 285 right over here, and then we're going to see what we can test for this formula. So, matter of fact, it says to make the food at 285, so why don't we just try that first? Let's do 285 minus 285. That's obviously going to be 0 regardless if it was absolute value or not. Now I just got to make sure it's less than or equal to 20, and yeah, it checks out, but we're not looking for that. We're looking for a formula where we put x in it. So we need to find a value where we can, wait a minute, we can put any value in here, right? Like I just did. What if we try x? Maybe that will work. We'll see. Let's see here. We can do our same thing like we did in the other problem where we can put x like this and x like this, and then we can add on both sides. So x equals 305 like we said earlier, and x equals 265, and I just added 285 on both sides. So that means that our range for this problem, although not required, it is recommended, is 265 and 305. We want to be in that temperature range. So if that's 20 meters off, 285 minus 20 is 265, which we already did. So I think this formula works. I mean, what do you guys say? I think it looks fine. It looks pretty good to go. So yeah, good thing we made that formula. If we made a wrong formula, we would have, well, first of all, our food would have tasted bad. It would have sucked. But it's fine. Go ahead and erase all that. But we will keep this. This is our answer for A. Now we want B. The recipe says to cook for 13 to 17 minutes. Make a formula that satisfies this requirement. So now, well, here's the good news. It's giving us our range, which means that we know that our range is 13 greater than less than x greater than less than 17. Now I just have to make a formula that satisfies this requirement. So we want, like, we don't want a huge margin. So since our formula is x17, since it's like 17 minus 13, so let's try the upper minus the lower. So 17 minus 13 is equal to 4. Yep. Does that sound correct? 17 minus 3 equals 4? 13? This thing? I thought so. Alright, so now we want our answer. Get up there. We want it less than or equal to 4. We don't want a huge margin. And now, x minus, actually, matter of fact, I'm actually not sure how to put it. What do you guys think? What do you think? Oh, wait, what? Hold on. What do you guys think? I think it can be, like, wait, you guys are giving mixed answers? How about that? Hey, how about that, huh? Yeah, you know what? X minus 13? Wait a minute. 13 minus x is 13, so 0. And then 17x is 4, so that checks out. What about 17? Some of you guys are saying that too. 13 minus 17 less than or equal to, because absolute value, -4, is 4. Oh, I think it checks out. These are both right. That's insane. All right, guys. Well, we just did that. Those are our answers. This one, and then these two. So there's that. All right, let me pause the video, and I'll be right back. Oh, and apologies about that. My mic actually did just die, so that was awkward. But we're back now. I got it plugged in. I don't know if you can see that, but it doesn't matter. It's plugged in. You can see the wire right there. See? So now, yeah, that's good for the scenarios. And if we didn't get that correct, then yeah, our dinner would have sucked, like I said. All right, now let's move on to the fun part. Graphing. Yeah! Hey, come on. We gotta, Algebra 1, you know? We gotta graph in Algebra 1. You're gonna do so much graphing in Algebra 1. So let me go ahead and pause this video, and I'm gonna erase it, and then I'm gonna put some graphing problems where we can use absolute value. All right, we're back, and now you're going to do some graphing. So let's go ahead and discuss on absolute value graphing. So first things first. Oh, I completely forgot to add arrows here. Make sure to always add arrows at the end of your graphs. And now you want to label our graphs. This is X, this is Y. Now, every single one of these points, it's in a 10 by 10 frame. So remember that for reference, 10 by 10, because that's pretty standard for graphing. I wanted to make it simple for you guys. Now, we're going to apply those stretches and compressions we talked about earlier in this video into action now. So let's just say we want to do f of x, and that just means function x. It's another way of saying y, but once you get into further stages of Algebra 1, you will want to use f of x eventually. So let's just say it's equal to absolute value of x. So we have to find our now here is the graph for f of x, because remember, we want points on the graph. So whatever x is going to be, we're just going to put down the graph. So I call it plug and chug. So I'll write that down. Plug and chug. So first, plug. So let's just say x equals 1. So when x is 1 on the absolute value, it'll just pop out as 1 because that is 1 unit away from 0, as we discussed. Now we chug. That means that y is equal to 1 since our output is 1. So that means that our first point will be there. But now, let's be honest. Let's just not do this a million times. I think we can all agree as people in the audience that if we just keep adding values, like if x is equal to 2, then like absolute value of 2 is 2, and then 3, and then 4, and then 5, and so on. So why don't we just, matter of fact, just put the points right here. So 2, 2, 3, 3, 4, 4, 5, 5, and so on and so forth. Same with the negatives. But, whoa, hang on. Slow down. This is not a linear graph where it's a line like this. Incorrect. Absolute value is different. But don't worry, absolute value is not as different from a linear. And matter of fact, absolute value is one of the easier ones to graph. And then we have the origin, obviously. When x is 0, that's 0 meters from 0, so 0. Now, -1. -1 is 1 unit away from 0. Positive. Remember, distance is not negative. So we don't even want to touch this area. These are no-show. Gono. So we're going to put that, then that, and then that, and then more, that, then that, and then we can make our line. So we can do this. This will go on to infinity. And then this will go on to infinity. Kind of like a V. So just remember, absolute value. Okay, so let's write this. Absolute value of V. V line for absolute value. Now that is the base function. So whenever it's just x for absolute value, this will be your line right there. Whoops, almost fell. Whoopsies. So let's go ahead and apply this to different problems. So since it is graphing, I'm not going to be like some teachers where they give you like 12 graphing problems and expect you to graph all of it, because let's be honest, we know graphing takes time. Like, we know we need at least like 5 minutes for pretty much every graphing problem. Well, maybe not the easy ones, but like we definitely need some time to like kind of grasp it. So anyway, here's our base function. We will want that for reference, as we will need to put some dotted lines, because some of our graphs we will want to use base functions as per reference. So let's go ahead and get some problems up here. I'm going to pause the video real quick, get some problems up here, and I'll be back. So let me try a new trick. 1, 2. Whoa. Okay. That was cool. We're back, and we got some problems behind us. 2 graphing problems. Now, normally teachers would just go in with problems like absolute value of x plus 5. But this is FEM. We are not like schools. We do things a different way. So, we're going to jump right into the pure maximum. So, here's our first problem. 2 absolute value of 1/3 x minus 5, solve for x. So, actually, matter of fact, let me change that real quick, actually. I'm going to remove that 1/3, because some of these problems, it's a little challenging. Because trust me, definitely like problems like number 2, it took me a while, especially one step that I'll show you, which you'll, and I'll prove it to you, because the problem is that teachers just don't prove it sometimes. Like, sometimes they're just going to say, like, we're not going to get into that. But we will. We will. And I will ask questions. I will answer questions in the comments. If you have questions throughout any of this, please ask me. Please ask me. That's literally my whole purpose. Like, trust me. I am here to guide through you and, like, make you successful in math. Okay, first up. Now, first things first, we want to identify transformations. Now, as I mentioned, we need a stretch. So, this 2 right here, since it's on the outside... Oh, whoops, hang on. Hold on. Wow, that was awkward. Okay, anyway, we want a vertical stretch, so I'm going to put V right here. That stands for vertical. Just remember that. V stretch, and then we can put it times 2. So, what this means is that it's going to stretch the graph vertically by 2, which means that, so when I say vertically, it means like, so let's just say like, this line is like the base function, but then a vertical stretch by 2 will make it like go more like that. So that's vertical right there. So vertical. And then now if this were like 1/2, it would be the exact opposite. So if this was base, that would be horizontal right there. It would be more stretch outward instead of like inward. So that's horizontal. Now I am taking a lot of space up. Don't worry. It's not going to be the end of the world if we do. I'll just have to erase it. Okay, next transformation. Now this thing, I haven't introduced it yet. That's inside the absolute value, which means that it's either going to be left or right. Now, here's a simple method to remember. Whenever it's -5, it's going to be to the right. Whenever it's +5, it's going to be to the left. This is because, basically, like I said, we want units from 0. So, if x is like -5, then it would be -10 times 2 times +2. So, basically, if this thing was a +2, x would have to be -5 for it to be 0. But TLTR, -5 is left, and +2 is right. And I will go through that and assist you along the way as we graph this. So this is right 5. And then this one's the easiest one. Negative is down, positive is up. Easy. This is because this is controlling more so the y value. So 2 is up 2. So that means our transformations are vertical stretch times 2, right 5, and up 2. So here we go. Let's go ahead and get our base function. So let's just put some dots over here. Draw our baseline. Now I'm putting it in dotted lines because it's just to assure you that this is not our final answer. So first things first, we want to do the translations first. So we're going right 5, so we're in increments of 2. So 1, 2, 3. We're going to end up right here. Up 2, so we'll be right here. This will be our starting point. And then we're stretching by 2, which simply means that instead of going like 1 forward, we're going 2 forward. So slope, rise over run. So we're going 1 over and then up. We're stretching 2. So, well, actually, wait. These are in increments of 2. My bad. It's kind of confusing. So yeah, instead of going like right here, we will go right here, and then this one right here, and then that one right there, and then that one right there. I kind of spaced it off, but it's fine. But that will be your final product, and make sure that it has arrows too. Oh, in future episodes we'll go over domain and range, but I'll let it slide for this episode. But next episode, definitely we're going over domain and range. All right, let's move on. Next graph, 1/2 4x minus 8. Now, this is why I wanted to delete that 1/3 x, because now that there's a 4 right here, we want to prioritize making sure that this thing is correct first. So let's identify transformations. So we have a vertical compression now, because it's 1/2, it's less than 1 instead of a stretch. So I'm going to put V comp, which just stands for compression. It's totally fine. Ask your teacher if that's allowed. Our teachers allow it. Vertical comp times 1/2. That just shows that that's what's happening. -1, down 1. Now, many students just put right 8. And you're probably wondering, Landon, why would it not just be right 8? Because it says that, right? Well, wrong. Because one thing, we have to make sure that we isolate the variables before we have to isolate the coefficients before we make a final executive decision. So this means that we have to divide by 4, since 4 is the leading coefficient of x. So that means that our final product, our new equation, would be 1/2 4 parentheses x minus 2. There we go. So then 4 times x is 4x. 4 times -2 is -8. So that pretty much checks out. So that means that instead of right 8, it's going to be right 2. And now our 4 here, since it's inside and it's bigger than 1, it's going to be a horizontal compression. Remember, when it's inside, when it's bigger than 1, it's going to be a compression. So h comp times 4. So that's that. And now we're good. We have a v comp times 1/2, h comp by 4, and minus 1. Now, here's the thing with horizontal compressions, with the exception of the vertical, is that basically x has to be at a greater number value. So that means that this time the values inside of the absolute value, they don't get affected. So let me go ahead and show you an example. So we can use our plug and chug method. So take 2 minus 8 is 0 because 4 times 2 minus 8 is 0, times 1/2 is 0, minus 1. So that means that 2 minus 1 is just right here. That's our first point right there. For number 2, plug in 4, because that's our next increment of 2. 4 times 4 is 16, minus 8 is 8, times 1/2 is 4, minus 1 is 3, so it would be 4, shoot, I messed it up, 3, so it would be up here. Next point is, to make it 0, so 0 minus 8 is just 8, 8 times 1/2 is 4, minus 1 is 3, so this would just be the exact same thing.